problem on the screen. So, are you able to see this one? Okay, it's visible. So here last class I have given one problem regarding the transient analysis and steady state analysis problem. So what is the value of I naught and V naught and I? Just post your answers. What is the I is the current flowing to the inductor and the I naught is the current flowing to the resistor of 6 ohms and voltage across the resistor 3 ohms. V naught value, I naught value and I value. Post your answers. Out of 20 16? 20. Yes. Classical. In which object? Out of 14 ka? The exact fill in the blank exact approximate. Alternatives diploma, diploma. Okay, here someone posted. I is I'm asking for the t greater than 0. 2 e raised to the power of minus t. 2 e raised to the power of minus t. Here I will write the answer, just a cross check. So here the current I of t means current flowing to the inductor, which is given by to the 2 e to the power of minus t amps for t greater than 0. Okay. And I naught is here. Just wait a minute. I will erase this total. So here I am writing the total answers. Here I have asked for the V of t and I of t and I naught of t. So here I of t I of t, here I of t is two cases. I am defining two cases individually. So I of t equal 2 amps for t less than 0. Okay. And 2 into e to the power of minus t class next class. So here this is I naught of t 0 amps for t less than 0 and minus 2 by 3. Is it minus 2 by 3? E to the power of minus t amps for t greater than 0 and v of t equal v of t equal which is voltage across the capacitor తర్వాత so v of t equal voltage across the inductor voltage across the resistor is given by which is 6 volts for t less than 0 and 4 into the power of what is minus t for t greater than or equal to 0. So these are the conditions. Just cross check your answer. Aishwarya 205 posted all the correct answer. Two into that is Madhavan 2 into e to the power of minus 3t. So Madhavan, you need to check the time constant value. Why not 2? Why not 5? Krishna Veni, only the fourth one is V naught is the right answer and I naught is also minus 2 by 3. I naught is the right answer, but you posted. Krishna is also right. Just okay. So okay, most of the students are posted right answers. Okay, ma. So here here, I will find out the answer again, once again, first one, because most of the students are not got a correct answer. That's why I will tell derive my expression once again. Just look at the screen. So here, I am asking find out the V naught value, I naught value, and I value for t greater than 0. So to find t greater than 0, you need to know the 2 less than 0. 2 less than 0. So here I am asking find out the V naught value and I naught value and I value for t greater than 0. So to find out this one, you should know how the circuit is behaving for t less than 0 conditions. So here the transient behavior is mainly depends upon the before the switching instant. Okay, before the switching instant. So here let us look at. So here I am asking the find the I naught value, V naught value, I value for t greater than 0. Here I have given a one node. The switch has been opened for long time. The switch has been open for long time. Has been open for long time. Okay. When the switch has been open for a long time, so how does it behave? How does it behave? So this is a circuit. Here the switch has been open for long time. The switch has been open for long time. When the switch is open for long time, okay, my circuit is looking something like this. Okay, it means here the current, the total current, here this voltage source is connected to this one. So as I said earlier, so whenever this 20 volt source is connected, so at t tends to infinity. First find out the at t tends to infinity. It is closed. It is open for a long time. It is open for a long time means it has reaches the steady state. It has reaches the steady state conditions. Whenever at t tends to infinity, it means it is open for a long time. So whenever it is open for a long time, it reaches the steady state conditions. Whenever the steady state conditions is reached, here how the inductor is behavior? The inductor is behaving like a capacitor. So for t less than 0, how my circuit will appear? This inductor here I am writing here for t less than 0. Okay, for t less than 0. So here this is my inductor. Already you know what is the voltage and current relation for the inductor. Voltage across the inductor is given by L into di by dt. So the current flow here it is a constant voltage source. So whenever the constant voltage source is applied to the circuit, it produces a constant current under steady state conditions. So here this current is constant under steady state condition. So the derivative of the constant equal to 0. So just remember one thing: the inductor will act as a short circuit to DC supply under steady state conditions. Okay, I am repeating again my sentence. So inductor will act as a short circuit for the DC supply under steady state condition. Here, how can I replace my circuit? This can be replaced by short circuit. So this can be replaced by short circuit. Whenever it is replaced by a short circuit, here there is no effect of this capacitor in your circuit. There is no influence of this resistor. So for this case, I can write. So what is I naught value here? From the looking the circuit, you can say I naught equal directly 0 amps. It is because it is shorted. Current cannot be. And what is the V naught here? Next, find out the I value. So I value is given by I is the current flowing to the inductor. It is given by 10 by 5. But it is 2 plus 3. It is a 5. There is no effect of this one. So how can I use 2 plus 3? You can get 2 amps. So what is the V naught here? V naught equal the current flowing through the 3 ohm resistor is 3 into I, that is 3 into 2, that is 6 volts. So 0 amps, 2 amps, 6 volts. 0 amps, this is the 0 amps. Okay, so this is the 0 amps and 2 amps and 6 volts. Okay, so which is correct for t less than 0. Now you need to find out how the circuit is behave for t greater than 0. How the circuit will behave for t greater than 0. For t greater than 0, if the switch is here, what I am doing? The switch is closing. The switch is closed at the instant of t equal to 0. So the switch is closed at the instant of t equal to 0. Yeah, the switch is closed. Okay, the switch is closed. Here I am closing the switch at t equal to 0. So here, just by looking your circuit, you can say, here, this voltage source is started. This here, the voltage source and 2 ohm resistor started. Means here the total block, this total one is gets blocked, started. So whenever it is started, okay, there is no current flowing through these started terminals because of this 10 volt source. Okay, so whatever the current is produced by this 10 volt source, only circulating to this one only. So this one. So in this circuit, the current is given by I equal 10 by 2. That is the 5 amps current is flowing in the first loop. So here in this circuit, here in this part, so no effect of source. No effect of 10 volt source. 10 volt source. So there is no effect of 10 volt source. This loop, come on. So this loop is a, this circuit is a, this loop is a source free circuit. Source free loop. A source free circuit. You can say it is a total circuit, it is a sub circuit. Okay, this sub circuit. This circuit, you can call sub circuit as loop or whatever. It is, for example, this is a sub circuit. It is a circuit. Here I have 3 loops: loop 1, loop 2, loop 3. So in the loop 2, in the loop 3, there is no influence of this 10 volt sources. So this loop is a source free loop. Okay. So how can I read my circuit? I can read my circuit. So I want to find out the, if I ask to find out the voltage across the 2 ohm source, so you need to consider this 10 volts. But here I am just asking the find out the voltage across 3 ohm resistor, 6 ohm resistor and 2 Henry inductor. These inductors are independent of the voltage source, because here the voltage, there is no effect of this voltage source on these parameters. So simply you can say it causes a, how can I write this circuit can be read down like this. Just wait a minute. Okay. So now my circuit is when t greater than 0, for t greater than 0, my circuit is, the remaining circuit is appear like this. So here, this one is present, but there is no influence of this one, this voltage source on these parameters. That's why I will write like here, I will read my circuit like this. So after that, so here, now it is a source free RL circuit. It is a source free RL circuit. For the source free RL circuit, here for the source free RL circuit, how does the for the source free RL circuit, here first of all, what are you doing here? There is a some initial energy is present. What is the initial energy? The initial energy in the inductor is given by the initial current in the inductor. So it is the initial current in the inductor is given by before the switching instant. That is I0 minus. So I0 minus initial energy in the inductor. This is the I0 minus equal to I0 or I0 plus equal to, what is the initial current before switching the instant? So before switching the instant, the current in the inductor is given by, which is 2 amps. So the initial current in the inductor is 2 amps. Okay. So this is the initial current in the inductor. Now there is a initial current in the inductor is present. So due to which some amount of energy in the form of magnetic field, that is 1 by 2 Li square. So 1 by 2 Li, I is 2. So if you substitute, we can get some amount of energy. This energy is equal to this 3 ohm resistor and 6 ohm resistor. And now it is act like a source. But this source is not a continuous source. It will whatever the source that inductor has will be vanishes after some time. That's why it is called only the transient response we can get. So here the initial current in the inductor is 2 amps. Due to this initial current in the inductor, it has some initial energy in the inductor. So therefore, whatever the initial energy that inductor have will deliver to this 3 ohm resistor and 6 ohm resistor over a finite interval of time, only for finite interval of time. So after that, it will be vanishes. It means it contains only source free response. So source free response means it is a transient response. So what is the transient response? So for the transient response, what is the current flowing to the inductor? So if you consider series RL circuit, okay, if you consider series RL circuit, so if I read my circuit, if I read my F4 circuit, how can I read my circuit? So I can read my circuit is like this. Here is the circuit. Okay. So here the current in the inductor is 2 amps. Okay. When I equal to 0, it is a 3 ohm resistor. It is a 6 ohm resistor. 6 ohm resistor. Okay. Just find out this one. Just read the. Okay. I want to find out the I. Okay. I want to find out the I. So here, just read the above circuit with the equivalent circuit, equivalent RL circuit. So this is the R equivalent. This is the L, which is given by, what is the L value? L value is 2 Henry. Okay. So here the initial current in the inductor is 2 amps. I want to find out the current in the direction which is given by I. So here this is the circuit. So for this circuit, here the current direction is like this. So it is I. So I want a I. So here now it is a source free RL circuit. On the source free RL circuit, what is the response? By looking your circuit, you can write it is a source free RL circuit. You can get the only the transient response which is given by I of t equal. So simply you can write A into e to the power of minus t by tau. The tau is the time constant which is given by L by R equivalent. What is the L value? 2. What is the R equivalent value? So R equivalent value equal 2 parallel. R equivalent equal 2, 3 parallel 6. You can get 3 into 6 by 3 plus 6, 9. This 2 Henry. Okay, so you can get 2 ohms. So 2 get cancelled, you can get 1. Time constant is 1. And how can you find out this? Now it can be written like this: I of t equal a into e to the power of minus t by tau. So this is the initial conditions can be obtained by using initial condition. Okay. So what is the initial conditions? Initial condition is the at t equal 0 instant. So I of 0 equal a into e to the power of 0. Simply you can get a equal I of 0. So you can replace the above circuit. What is the I of 0? What is the initial current? So initial current is given by, which is given by 2 amps. So if you substitute this one, you can get I of t equal. So what is it is? It is a 2 e to the power of minus t value is a 1 e to the power of minus t for t greater than 0. So it is the answer for t greater than 0. Just cross check your answers. Okay. So here this is the answer. No. This is this is your answer. 2 into the power of minus t. So 2 into the power of minus t. 2 into the power of minus t. Now here I am retrying my circuit, original circuit. Okay. So this is the current. Current in the inductor is given by 2 into the power of minus t. Here voltage across the this is the V naught, which is given by 3 ohm resistor. So which is the I naught. So I want to find out the what is here. 6 ohms. I think it is a 6 ohm. The 6 ohm resistor. Now here it is open. Now here, how these two resistors are connected, how these two resistors are here. Now this act like a voltage source. Just look at my cursor. So here this act like a current source. This inductor is a current acting like a current source with a current of I equal to the power of minus CT. Now this current is acting as a current source. This inductor is acting like a current source and will produce some current and it will distribute it equally to 3 ohm resistor and 6 ohm resistor depending upon the resistor value. Okay. So here this current is this is the current in the inductor. The inductor current is connected parallel to the 3 ohm resistor as well as 6 ohm resistor. So this 3 ohm resistor and 6 ohm resistor are connected in parallel to this one. Okay, in parallel to this one. So I want to find out the current in the this 6 ohm resistor. So by using current division rule, you can find. So here, this is the I now. This is the I. How can I write this one in this direction? How can I write I equal? It is a. This can write I equal minus 2 e to the power of minus t. So in this direction is current in this direction. Current in this direction is okay. Current in this direction is this one. Okay. So in this direction is current is 2 into e to the power of minus t. But opposite direction is it is given by, for example, opposite direction is given by 2 minus 2 into e to the power of minus t. Here the current is given by, for example, let us say this is the Ix. I am assuming the current direction is Ix. Ix equal minus into Ix equal. For example, I am assuming the current in this direction. Okay, here by you applying a KCL here, you can get the current in this direction, which is given by Ix equal minus 2 e to the power of minus t. Okay. So here, now this current is equally divided to the 6 ohm resistor and 3 ohm resistor. Now by applying current division rule, I can get I naught equal total current Ix into, this is total current Ix into opposite resistance 3 by 3 plus 6. What is the Ix value here? Minus 2 into e to the power of minus t and 3 by 9. So you can get minus 2 by 3 e e to the power of minus 2. So which is the I naught for t greater than 0. So let us take the cross check your answer. I naught e to the power of minus 2 by 2. So this is the answer. This is your minus 2 by 3 e to the power of minus. So here you can get you got uh, I of t, I naught of t, and v of t for t less than 0 as well as t greater than 0. So this is for the last problem. So I hope it is clear for all of you. If you have any doubt, you can ask me now. Okay. And I will give you one more example with a dependent source. How the circuit will behave here if the dependent source is present. Another example. So here, BA or MA? Both. Both. Maximum also. Maximum also. Third year, or second year? Third year. Okay, here. So look at this one. So assuming that the I of 0 equal to none, there is an initial current in the inductor. So I use this one, the current in the inductor I mentioned with I labeled with a letter I. Okay. So assuming that I of 0 equal to none, and calculate the I of t and Ix of t in the circuit. Okay. For t greater than 0. So for the t greater than 0. So here there is no mention. I didn't mention any switching instant here. So this is a circuit. Assuming that I of 0 equal, there is a current initial current in the inductor is given by 10 amps, and calculate the I of t, and Ix of t. I of t is the current going to the inductor, and Ix of t is the current going to the resistor in the circuit of above figure. So this is our problem. Okay. So here now it is a. Anybody just tell me, it is a source free circuit or a force circuit? Can I get a steady state response at the time tends to infinity or only transient response for this particular problem? So here I have given a dependent source, not an independent source. Okay, dependent source, not an independent source. So here already I said, so whenever there is a independent source are present, so the independent source is always depends on, whenever there is a dependent source is present, the dependent source is always depends upon the other parts of the circuit. Okay. So here, this dependent source, even though it is a source, this dependent source is always depends upon the current in the inductor. If the current in the inductor is 0, there is no voltage across the 3 volt source. Okay. The current in the inductor is present, and at that instant only there is a voltage is present in the dependent source. So if the current is 0, the voltage across the dependent source is also 0. Now, here, find out this circuit to find out the response. So here, final response of the circuit is only transient response. Final response is only transient response. So no steady state response. So why the no steady state response? So why the no steady state response? The steady state response is 0 because so here this circuit is a source free circuit, because if it is a independent source, we can consider it is a we can say it is a source force circuit, but it is a independent source. Now it is a dependent source. The dependent circuit is always depends upon the other parts of the circuit. Okay, depends upon other part of the circuit. So here, so this is my circuit. Okay, so here, this one, this current source, this inductor act like a source. Okay, act like a source. Whenever the current is 0, this voltage source is, when the current is in the inductor is 0, the voltage source is 0. When there is a current present in the inductor, there is a voltage is present in the dependent source. So here, to find out the Ix value and I value, here first of all you need to find out the Thevenin equivalent circuit across. Okay, so here final only we can say the final response of the circuit is only a transient response. So it can be considered as a RL circuit, like RL circuit only. So even though there is a voltage source is present, but there is no effect of this voltage source, we cannot consider this voltage source independently, because it depends upon the other part of the circuit. So that's why I am not considering this one. I can say it is a RL circuit with source free RL circuit. I can call it as a source free RL circuit. So source free RL circuit. So for the source free RL circuit, you can get the transient response. In the nature of the transient response nature is simply you can get I of t, the current in the inductor is given by I of t equal, there is I of 0 initial condition into e to the power of minus t by tau. Okay, so where t is the time constant which is given by L by R equivalent. So you need to find out this R equivalent. We need to find out this R equivalent. So to find out this R equivalent, how can you find this R equivalent? Here there is some special case. Okay, So how to find out this R equivalent? First of all, you need to consider. Okay. So just consider. Come on. Here I got a notification. The meeting will be end soon. All of you just leave the meeting and rejoin again. So before leaving, drop your roll numbers in the chat box.